chemistry students. This is the last page of worksheet 10 or 9 if you're looking at the 2020 spring Unit 4 packet. So let's work through these. Formaldehyde may look confusing to start with, but let's just do the Lewis structure for the molecules involved or for the atoms involved. So carbon, hydrogen, and oxygen with its 6 valence electrons. Oh, well, that'll be fun. So let's actually do this. Here we go. All right, now we're going to put carbon because it can make the most bonds in the center. And it looks like there's 2 hydrogens attached directly to the carbon. So we'll try and work through that here. So we'll do a single bond there, and then we'll do a single bond here to this hydrogen. And then the oxygen can form 2 bonds, and the carbon can form 4. It's already formed 2 to the hydrogen, so it has 2 left. So it looks like a double bond is going to be our best option here. So that'll make our structural formula for this molecule something like this. Single bond to the H's and a double bond to the oxygen, and then let's put those lone pairs out there on the oxygen. Now, the ethine. Okay, so we got carbon, which can do 4 bonds, and hydrogen, which can do 1. And let's pay close attention to this C2H2 thing that's going on. All right, so let's make the carbon atoms the central atoms. And they'll be at least single bonded to each other, probably more than that by the time we're done. And then we've got to do 2 hydrogen atoms according to the formula, so I'll put those on opposing sides here. Single bond those. Now, in order for carbon to have an octet, right now this carbon atom has 1, 2, 3, 4, 5 valence electrons. So to get an octet, share here, and share here. And you have this triple bond, and then that'll make both of the carbons have an octet. 1, 2, 3, 4, 5, 6, 7, 8. And then for this carbon atom, 1, 2, 3, 4, 5, 6, 7, 8. Structural formula for that. Do that triple bond there. And put the hydrogens over here. And that's it. All right, nitrogen. Nitrogen, you should be able to remember that the formula for that is N2. It's got nitrogen atoms in it. The way this is going to work, nitrogen, with its 5 valence electrons. Share those, and share those. And you have nitrogen triple bonded. All right, we'll do some carbon dioxide. Should be able to write the formula for that because it's a binary molecular compound. It's got some carbon, we've got a carbon atom and some oxygen atoms in it. All right, carbon is the central atom. Carbon can form 4 bonds. Each oxygen can only form 2 bonds. So we'll share those there, and then we'll do this other oxygen over here. All right, and that satisfies the octet rule for all the atoms involved. Let's see, put the lone pairs where they go. Alright, hydrogen cyanide. So we'll draw the Lewis dot diagrams. Alright, carbon can make the most bonds. We'll make it the central atom. Hydrogen can do 1, so we'll single bond that. Then nitrogen can do 3 bonds. And you satisfy the octet rule for all of the atoms involved. That's what it'll take. So H, C, triple bond to N, and then nitrogen still has a lone pair out there. That's a problem with the worksheet. Tetrafluoroethene is not C2H4. That would be C2F4. I'll have to go back and change that on my copy of the worksheet. So anyways, let's do our carbon and our fluoride, our fluorine. Right. So we'll make the carbons the central atoms. Right, and then we're going to put our fluorines out here. Each of those can single bond. So there's a single bond. Here's another F. And it can single bond. And then, you know what? Let's put that over here. There's that. And then the carbons, to satisfy their octets, they'll have to double bond to each other. So you'll end up with something like this. And on molecules like this, you can see why the structural formula is so much better than the diagram that shows the sharing, because there's just so much going on in this diagram. But this one is simplified enough that we can see the bonds. And there's just a lot of lone pairs out there on those fluorines, but that's always with the halogens. Let's see, dichloroethane. By the way, you might notice that the enes have double bonds in them, and the ynes have, well, it's going to be a triple bond, just like the ethine up here. So that's not coincidence. Anyways, let's fix that. Or let's draw it. So here's the carbon. Here's the chlorine. Alright, the two carbons are going to be central atoms. Got a little bit ahead of myself there. And then we got two chlorines to put in here. Each chlorine can do a single bond. Oh, that's a chlorine, sorry. Oh, no, it's not. Well then. Chlorine's over here. So that's what happens when you get a text message while you're trying to work. You get distracted. Now, carbon can form up to 4 bonds. And you can see right now these carbon atoms, they don't have an octet. 1, 2, 3, 4, 5, 6. So they're going to share here, and they're going to share here. Now each carbon atom has an octet. See, 1, 2, 3, 4, 5, 6, 7, 8. And the chlorines also have an octet. So, structural formula here, triple bond the carbons, throw a chlorine on each end, Cl, Cl, and a bunch of dots out there for all those lone pairs. And that is it.